Okay, starting off lesson 5.5, multiple angle formulas. Okay, here we have a scenario where we will apply one of the double angle formulas. And cosine of 2x, if you look at your yellow sheet, there's actually 3 different expressions that it's equivalent to. So you just have to choose the expression that best suits the situation you're working with. Okay, so cosine of 2x, I'm going to substitute 2 cosine squared of x minus 1. Okay, and then I have plus cosine of x equals 0. Okay, now I have a quadratic structure. Okay, so I could factor this. I have 2 cosine squared x. Let me get rid of this here for the time being. And then I have minus 1 cosine x plus 2 cosine x minus 1 equals 0. Okay, well, how did we get this? Well, I just need to find 2 numbers that add up to 1, and then that also multiply to give me negative 2. And those 2 values are negative 1 and 2, which I have right here. So I just split the middle term up into these 2 terms. Okay, now I can apply the grouping method. Alright, and I have this. I'm going to factor out a cosine x. Leave me with 2 cosine x minus 1. And I have plus 1 times 2 cosine x minus 1 equals 0. Alright, and then I have 2 cosine x minus 1 times cosine x plus 1. And that's equal to 0. Alrighty, so now I'm going to set each factor equal to 0. Let's solve each of these equations. Just add 1 here. I get 2 cosine x equals 1 divided by 2. Cosine x equals 1/2. Okay, now here I have hypotenuse, which is always positive, adjacent, which is positive. So that means I'm in quadrants what if adjacent is positive? I'm in quadrants 1 and 4. Alright, so here's 1, that's 2, and then this is going to be square root of 3. And that will be 60 degrees there. Okay, so what are my rotations in order to obtain these terminal sides? Well, for this one, it's 60 degrees, which is the same thing as pi over 3. And for this one, it's 300 degrees, which is 5 pi over 3. Oops. What's going on there? Alrighty. And let's go on to the other equation. Minus 1, so cosine of x equals negative 1. And let's see here. That's 1 over 1. Hypotenuse is always positive. Adjacent's negative. So when are adjacent and the hypotenuse the same? That's when we're over here on the negative portion of the x-axis, right? Adjacent's negative 1, opposite is 0, and hypotenuse is 1. Okay, so what's the rotation? The rotation is 180 degrees, or x is equal to pi. Okay, now to complete our answer, I have 3 solutions going from 0 to 2 pi, but now I want all the solutions for this equation. So I have x equals pi over 3, I have x equals 5 pi over 3, and x equals pi. Now what do I add to all these? Because I'm working with cosine, I'm going to add 2 pi in to all of them. And covers all the solutions for this equation. All right, done with that. All right, for example 2, it's telling you to use the double angle formula to rewrite the equation. And we're also going to sketch the graph going from 0 to 2 pi. Okay, let's see here. I could factor out a 3 from the expression, leaving me with 1 minus 2 sine squared x. And I could substitute what in for that? I could substitute cosine of 2x. Okay. All right, now this goes back to previous chapters where we graphed our trig equations. All right, so the amplitude is 3, with absolute value of 3, which is just 3. And the period, the normal period is 2 pi, and I divide by b. In this case, my b is 2, so my period is going to be pi. And I'm dividing it into 4 parts. So I take pi and I divide by 4. And that's all we need to graph now. So let's make a little grid here. And what am I moving by? I'm moving by force. So pi over 4. This is 2 pi over 4, or pi over 2. 3 pi over 4. Then I have pi. And it wants me to go to 2 pi. So then I have 5 pi over 4. 6 pi over 4, or 3 pi over 2. Then I have 7 pi over 4. And then I have 2 pi. And the amplitude is 3. And I'm working with cosine. So I start up at the maximum, go down to 0, down to the minimum, back to 0, up to the maximum. All right, and then same thing again. All right, there's the graph going from 0 to 2 pi. All right, let's go to the next example. All right, example 3, I have to find sine of 2u, cosine of 2u, and tangent of 2u, given this information here. Okay, so what do we have here? This is opposite, hypotenuse. This here implies that we're in quadrant 1. So opposite is 3, hypotenuse is 5, and the other side will be 4. So that's opposite, hypotenuse, and adjacent. Okay, and then sine of 2u. All right, this is my u here, my angle u. Sine of 2u is the same thing as sine of u, or sine 2 sine of u times cosine of u. All right, so 2 times sine. Sine is opposite over hypotenuse, 3 over 5. And cosine is 4 over 5. And simplifying this, we get 24 over 25 for sine of 2u. All right, let's go to cosine of 2u. And that's equivalent to 2 cosine squared u minus 1. And you could have used other variations. You'll still get the same result. Cosine of u is 4 over 5. All right, so then I'm squaring that though. Watch out for that. Minus 1. And then I end up with 32 over 25 minus, need a common denominator, 25 over 25. So I end up with 7 over 25 for cosine of 2u. Alrighty. Then there's tangent of 2u. Alright, tangent, I could break that down into 2 tangent u over 1 minus tangent squared u. Alright, and tangent is opposite over adjacent. Alright, 3 over 4. So I have 2 times 3 over 4 over 1 minus 3 over 4 squared. Alright, just be careful working this out. Alright, need a common denominator. 3 over 2. I have 7 over 16. I get 16 over 7. 16 over 7 cancels out. Then I get tangent of 2u is equal to 24 over 7. Okay, and that's all there is to it. We're done with the chapter now. If you have any questions, if you need any clarification, please make sure to ask. And here's some extensions from the double angle formulas. All right, be aware that these exist. All right, these may come up at a certain point in time. All right, begin the assignment at the bottom of the page.